Hey everyone, today we are going to work on interpreting the slope and y-intercept of a linear function. And this lines up with IXL assignment H5B. So in order for us to interpret, so discover what the slope and y-intercept mean for a particular real world scenario, we need to just do a quick little refresher of what those are and where they are on the graph. So when we're given an equation, we're focusing on that slope-intercept form. So y equals mx plus b, where m is representing your slope and b is representing your y-intercept. Then when they're on a graph, if we look over here, your b is your y-intercept, which means it crosses the y-axis. So it will always be somewhere along your y-axis. And then your slope, another name for slope is if your y-intercept is 0, it can be called the constant of proportionality. It can always be called your, rise over run. You can refer to it as your rate of change, but that slope is what your line is either increasing or decreasing by. And that is something that you need to calculate and find out. Couple little things to remind you of is when it comes to interpreting, something that helps me is remembering that your y-intercept, that b, the way that I remember it's b for y-intercept is that's where your graph begins. But when it comes to word problems, it's going to be the beginning, or a lot of times your initial or your starting value. And then your m is that movement. It's how much your graph is moving by. So we can think of that as how much either something is increasing by in price, it's decreasing by, it's that rate of change. So a lot of times it can be a rate like cost per hour or miles per hour. So those are the kind of those key phrases that we're going to be looking for when we are interpreting, when we are explaining what those two things mean from either, a graph or an equation. All right, let's go over to IXL because the best way to practice this is by actually doing examples together. Right, here we are on IXL. Remember that code is H5B. Interpret the slope and y-intercept of a linear function. And please don't forget that IXL has some great resources. So if you finish watching this video and you still have some questions or want to, see it in a different perspective, you can click here to learn with an example, or click here and watch an awesome video that IXL has made. All right, let's scroll down so we can see the full question. Fred hires Trident Electric Company to install a new light fixture. The electric company will charge an initial fee for the service call. In addition, the total cost of the job includes an installation fee that will depend on how long the job takes. This situation can be modeled as a linear relationship. And then they've graphed it for us. In this case, we are being asked to explain what the y-intercept of the line tells us about the situation. So the first thing is I just want to find the y-intercept so I can know that number value. Then I can go back and look at my labels, reread the word problem, and see what it means. So your y-intercept would be right here, which means our y-intercept, our b value is $25. If that didn't already have the dollar amount, remember that because it's the y-intercept, you would look at your y-intercept label. And so this is kind of showing us for each thing, what is our total cost. Now, normally that's all we really need, but remember your y-intercept can be written as an ordered pair. So if we write it as an ordered pair, it would be 0, 25. So we already said that 25 is the cost, so I'm just going to put a dollar sign. What would that 0 represent? Because that's where our graph is beginning. Well, that 0 is our X value, and that represents the total time. So that tells me that when this electric company comes out and they have spent 0 time working on it, I have to pay $25. We scroll up a little bit. I know these markings are not going to work, so let me clear those. We can see here that it says that electric company is going to charge an initial fee, but then it will also have an installation fee depending on how long the job takes. Well, what we just found was that initial fee, because our time is 0, which means they've spent 0 time installing stuff. That's just that fee that they're going to charge for even coming out and working with us. So now that we know that, let's read our answer choices here and see if any of them match with what we just discussed. So after the initial fee, Fred will pay $40 an hour. Well, that's nothing at all like what we discussed. Including the initial fee, Fred will pay $225 if the job takes 5 hours. That could be true. I don't really know, but it's not what we're being asked to find. We're specifically being asked to find what the y-intercept tells us. So that's not our answer. The initial fee for the service call is $25. There we go. That sounds right. That's what we just discussed. That's that initial fee that they're going to have to pay. But let's go ahead and read the last choice just to make sure. After the initial fee, Fred will pay $25 an hour. I don't know. That could be true, might not, but it doesn't really matter because it's not what we're being asked to find. So this would be our correct answer. That's what the y-intercept means in this situation, that's our initial fee that we're going to have to pay. All right, let's look at the second one here. Emmett is planning a party at an escape room. The escape room will charge Emmett a booking fee and an additional cost per person attending the party. This situation can be modeled as a linear relationship, and here it's shown. So let's scroll down to see our question. We want to know, what does the slope of the line tell you about the situation? So this time we're being asked to identify our slope. So we don't really care about that y-intercept per se. We don't care about what that beginning fee is going to be. We want to know the slope. So let's just start off like it's not even necessarily an interpretation problem, and let's discover what that slope is, because that is going to be part of our answer down here. I can see that I have lots of numbers, 50, 20, 25, 250. I'm going to have to check this out. So remember, you select any 2 points on your line to calculate the slope. Just make sure that you pick a point where it crosses a grid line perfectly, because we don't want to do any estimation. So now we need to do our rise over run, also known as our change in y over our change in x. So do note that our y values are increasing by 50. So every time we go up a block, it's really going up by 50. So 50, 100, 150, 200. So our change in y increased by 200. And then our change in x, look and see what that's counting by. Our x's are counting by 2s. So every time I go over a block, I'm counting by 2s this time. So 2, 4, 6, 8, 10. Let's simplify that. 200 divided by 10 would be, oops, I don't know for sure if it's $20 yet, so I better not jump the gun. But it would be 20. Now, to get our label is going to be in the same order, our y over x. So our y label is cost, so it would be $20 per our x label, which is number of people. So it's $20 per person. All right. So that may be all we need in order to answer our question, but let's read our answer choices and see. So our slope is 20 bucks, and we can very easily interpret our slope by honestly just picking our labels, and our labels go in the same order, y over x, $20 per person. So option 1 here says the booking fee is 50 bucks. Could be true, but that doesn't tell me what the slope is, so it doesn't matter. After the booking fee, the party will cost $20 per person. Yeah, that's what we have, $20 per person, so that's probably our answer. Well, let's keep reading. After the booking fee, the party will be 25 per person. Nope, we figured it would be 20. And then including the booking fee, it would cost Emmett $250 total for 10 people to attend. That could be true, but that's just interpreting a single point on our graph. That's not specifically interpreting the slope, which is the cost per person. It's that rate of change. So therefore, that is not the answer we're going to select. I'm not even going to check to see if it's right or not because it doesn't identify the slope. So this one right here is our answer because it is the slope. It's going to cost $20 per person. All right, let's look at this one. Eli is using donated fabric to make bandanas for the dogs at the Pampered Pups Rescue. The amount of fabric he has left decreases as he makes each bandana. That makes sense. The situation can be modeled as a linear relationship. Oh, this is fun. We want to complete the statement that describes the situation. So we have 2 drop-down boxes. He's going to start with so many square yards of fabric, and he uses so many for everyone he makes. Well, which one of these, just so we can continue to make that connection, is going to be our y-intercept? Well, our y-intercept is where our graph begins, so it's always going to be that initial value. So that's going to be this first box right here, how many square yards of fabric he starts with, because that would be that initial, that beginning point. So if we want to find our y-intercept, remember your y-intercept is where your graph intercepts, where it crosses the y-axis, which would just so happen to be this point right here, and I made that way too big that we can't see our number, giving us the y value of 16. So that means he is going to start off with 16 yards of fabric, and looky there, that's an answer choice. And then we want to know, and then he uses blank for everyone he makes. Well, if we look at these answer choices, this helps confirm to me that we're finding the slope, because remember, your slope is always typically represented as a fraction. Here they're splitting it up, but either way, it's a rate. So it's going to have 2 different labels, like the one we just did, dollars per person. That's 2 labels, dollars and people. Or it could be, if we're buying fruit, cost per pound, price per pound. In this case, it's the square yards of fabric per bandana. So let's find our slope. If we select a second point here, that would be this one right here. And remember, for your slope, it's your change in y over your change in x, also known as rise over run. Look at what your graph is counting by. My y's are counting by 2s. So if I go down a square, I go from 16 to 14, really meaning I decrease by 2. And then my x value, that's counting by 4s. So I go over 4, 8. If we simplify that fraction, that would be -1/4. Now we need our labels. I'm going to write this down below so we can see it better. But our labels match up with our numbers. So this -1 is our y value, meaning we're going to look at the y label, which would be the yards of fabric. So yards of fabric. And then the 4 is our x value, which would be the bandanas made. If we look at our answer choices here, look, that'd be the second one here, 1 square yard for every 4 bandanas. Now hold up, there's not a negative sign there, but I got a negative in my answer. How does that work? Well, the negative is represented by this word right here. He's using it, which means if he's using that 1 yard of fabric, it is going away from what he started with. So sometimes our negatives in problems like this can be addressed in word form. So Eli starts with 16 square yards of fabric and he uses 1 square yard for every 4 bandanas that he makes. All right, let's go ahead and do one final question here, and we'll make it one of these higher level SMART score ones where it has both parts so we can, practice both interpreting the y-intercept and slope. Even though make sure you read the beginning questions carefully because you only have to find one or the other, so be careful when you read those. So at the end of her camping trip, Carla deflates her air mattress. The amount of air in the mattress slowly decreases. This situation can be modeled as a linear relationship. We want to complete this statement. So the air mattress has so many cubic inches of air when Carla starts deflating it, and then the mattress loses so many cubic inches every minute as it's deflating. This time, both of them in my drop down is just a single number. So how do I know which one's the y-intercept and which one's the slope? Well, one thing that cues me in is if we read this first sentence, it says it has this much air when she starts deflating it. So that means that's going to be the initial value. That's the initial amount of air that the air mattress has. And anything dealing with the initial, with the beginning amount, is going to be our B. It's going to be our y-intercept, which in this case would be 18,000. Another reason I know that to be the case is if we look at our second sentence here, it's saying that it's losing, which makes sense because my graph is going down, it's decreasing, so the losing aspect would represent that negative slope. And then it's so many cubic inches every minute. So they've kind of already done the slope for us. So it's saying that this is the y value, and then if it's every minute, it's going to be every 1 minute, which would be like our x value. So a lot of times when it's simplified like this, where it's per 1 single unit, we just write it like this. That's why it's, when we talk about speed, 50 miles per hour, that's 50 miles per 1 hour. But we just write it as per hour, or in this case, it's just how many cubic inches per minute. All right, now that we've discussed how we know this number is representing our slope, let's figure out what our slope actually is. So our second point here, looking for it to cross a grid line perfectly. I don't want to do one like this, because even though it kind of looks like it's halfway, I mean, going from 16,000 to 14,000, that's a big jump there. I can't guarantee that that really is smack dab in the middle at 15,000. So we got to find the one that crosses a grid line perfectly so I can know its exact value. And then let's find our slope. So we want our change in y over our change in x. Another way of saying that is rise over run. So our y's, notice that it's counting by 2000s, but don't let that freak you out because it's really just like counting by twos. We're just adding 3 extra zeros. So we go 2,000, 4,000, 6,000, 8,000. Now remember, you can always double check by turning this like a table where you subtract. So 18,000 and then it goes down to 10,000 would be 8,000. Then for our change in x, this is counting by halves. It's just showing it in decimal form. So a half, 1, 1.5, 2, 2.5, and we'll put it in decimal form. And once again, we can look at this 2.5 minus 0, 2.5. All right, on big numbers like this, you definitely have permission to use a calculator to simplify. So 8,000 divided by 2.5 would be 3,200. And if we want to double check our labels just to make sure it really matches what the story says, it's always your Y label first, which would be cubic inches. So I'm just going to write that as inches cubed by your X value, which in this case, because it divided evenly, is 1. So it would be 1 single minute, which does in fact match with what our story here says. So remember to always look at those labels when you're identifying and interpreting what your slope means. All right, is your guys' turn to try it. Do remember that you have this draw it tool here. So if it helps you to draw those points and draw your lines on your graph, just like I modeled in the video, you can easily do that by clicking on the pencil down here and writing on the IXL screen yourself. All right, if you have any questions, make sure to attend a help session or send an email. Bye, everyone.